Hello everyone. Joining processes are the processes that use for joining metal parts and metal fabrication work. It consists of four types, which are welding, soldering, brazing, and adhesive bonding. One of the only important joining processes is welding. So in this video, we will tell you about 9 types of welding.
Oxyfuel gas welding, or we can call it as OFW. Oxyfuel gas welding is one of the most important types of welding process. It is done by burning of fuel gases with the help of oxygen, which forms a concentrated flame of high temperature. This welding process can be used to join most of common metals like cast iron, copper, aluminum, and steel. So the next is principle of oxyfuel gas welding. This is a process of joining metals by application of heat. The required heat for welding is generated by a flame caused by the chemical reaction. The fuel gas, commonly acetylene, when mixed with proper proportion of oxygen in a mixing chamber of welding torch, it is produce a very hot flame. With this flame, it is possible to bring metals to a molten state and cause a fusion of two pieces of metals. Then, for the equipments of oxyfuel gas welding are welding torch. Welding torch are most important part of oxyfuel gas welding. There are valves for each gas which control the flow of gases inside the torch. Then the next is cylinder. There are two cylinders in oxyfuel gas welding. The first one is oxygen cylinder. For proper burning of fuel, appropriate amount of oxygen required. This oxygen supplied by an oxygen cylinder. Then the other cylinder is fuel gas cylinder. Gas cylinder is filled either by oxyacetylene gas, hydrogen gas, natural gas, or other flammable gas. The fuel gas selection is depend on the welding material. Then the next is pressure regulator. Both oxygen and fuel gases are filled in cylinder at high pressure. These gases cannot use at this high pressure. So, a pressure regulator is used between flow. Then, the next, gas hoses. The hoses used to make the connection between the torch and the regulator must be strong, non-porous, light, and flexible enough to make torch movement easy. Then, the next is metal clamp. A metal clamp is used to attach the welding hose to a nipple. Then the last is filler material. Filler material are used to supply additional material to the pole to assist in filling the gap, and it forms an integral part of the weld. There are several advantages of oxyfuel gas welding. The first is portable and most versatile process. The next, better control over the temperature. Then, better control over filler metal deposition rate. And suitable to weld dissimilar metals. And the last is low cost and maintenance. There are also disadvantages of oxyfuel gas welding. The first one is not suitable for heavy section, less working temperature of gas flame, slow rate of heating, not suitable for refractory and reactive metals, larger heat affected area, and the last is flux shielding is not so effective. The next is application of oxyfuel gas welding. There are several applications of oxyfuel gas welding. The first, most common application of oxyfuel gas welding is repairs work. Then, fabrication of sheet metals. Thin to medium sheet metals are easily welded using oxyfuel gas welding. Then the third is in aircraft industry. Oxyfuel gas welding is used in joining various aircraft parts. Then the last is in automotive industry. Oxyfuel gas welding used to weld parts of the frame and the chassis.
Now, we are moving to the next processes, the process named as gas tungsten-arc welding. The definition of this welding is an electric arc welding process that produces an arc in the workpiece. The weld is shielded by the gas which forms an envelope around the weld area. The equipment used in this process is welding machine or power supply, electrode holder, and tungsten electrode and the shield gas supply and control. Hence, usually there are additional controls such as current control, etc. The essential part is that make an arc in the workpiece by the shielding gases. The advantage of this process is that it can produce stronger weld result due to deeper penetration and higher corrosion resistance. The second one, it can produce clean weld result. And the third one is that the metal liquid is not contain air. The fourth one is that it states that it does not produce much smoke. And the fourth one is that rare deformation happen. However, the disadvantage of this process is that it enables to have a big number of productivity, or it can be said that it have low weld productivity. And the second one is that the burn back may happen during the welding process. And the third one is that porosity weld defect or small hole often occurs due to inability to protect the welding surface. And the fourth one is the tungsten inclusion can occur. Now, the application of the gas tungsten arc welding is various. The first picture shown the process of making aircraft frame that done using this type of welding, while the second application of gas tungsten arc welding is for a jet engine casing and as a rocket motor casing.
The plasma arc welding, which is a cutting method, was discovered in the year 1953 by Robert Merrill Giggs and recognized in the year 1957. This procedure was unique as it can perform accuracy cutting on both thin and thick metal. This kind of welding is also competent for spray covering hard metal on new metal. This welding process is used in the welding industry for bringing superior control toward the arc welding method in the minor current ranges. Plasma arc welding is a process where a coalescence is produced by the heat, which is developed from a special setup between a tungsten alloy electrode and the water-cooled nozzle, or between a tungsten alloy electrode and the jet. This process employs two different gases for two different purposes. One gas is used to form the arc plasma, second gas is used to shield the arc plasma. Plasma gas supply throughout the nozzle turn into ionized. The shielding gas supplies throughout the external nozzle and protect the joint from the environment. There are some advantages of plasma arc welding. First, constricted opening or orifice give you more concentrated heat in smaller area. Second, more stable and does not get deflected from the base metal. Third, has deeper penetration capabilities and produce a weld. Fourth, give high speed weld. Fifth, less distortion of base metal, and then more control on small welding areas. Plasma arc welding also have disadvantages, which are orifice replacement is necessary,
Its equipment are very much expensive. An individual needs more skill to use plasma arc welding, and then last, nozzle gets melt which must be changed frequently. There are some applications of plasma arc welding. First, it is used to join stainless steel tubes and pipes. Second, used to weld small components of metal. Third, can be used in industries like aerospace as well as marine, and then used in thin electronic chips and medical setup.
Diffusion bonding is one example of the type welding. As the principle of the diffusion bonding is a solid-state joining process between two metals in the way that the microstructure and mechanical behavior of the bond becomes identical to the parent materials. In the diffusion bonding, there are two main mechanism stages that we should to know. The first stage is oxide layer on surface aspartite just before the initial contact, and the second stage is metallic bond formation between rupture oxide layers due to microplastic deformation on the aspartite. There are some advantages and disadvantages by using this diffusion bonding process. The advantages are the joint has same mechanical and physical properties as parent material, free from interface discontinuity and porosity. Both similar and dissimilar materials can be joined by diffusion bonding process, provides good dimension tolerance, low running costs. It is simple in working, not use filler materials and flux weld in complex shapes, and the disadvantages itself are high initial cost, takes more time than the other welding process, surface preparation of welding plates are more critical and difficult, size of the weld is limited, not suitable for mass production, highly depend on welding parameters like surface finish, welding materials, temperature, and pressure. The application of the diffusion bonding process are mostly used to weld refractory materials in aerospace industries and nuclear industries like the figure shown. Besides of that, the diffusion bonding is used to weld titanium, zirconium, and beryllium metals and its alloy, weld nickel alloy like in Cornell, and weld dissimilar metals like copper and titanium, copper to aluminum, and etc.
Brazing process. So basically the process of brazing has been known for at least 5,000 years and must be one of the oldest of all known metal joining techniques. So brazing is a joining process wherein metals are bonded together using a filler material with a melting or liquidized temperature that greater than 450 degrees Celsius, or we can convert to Fahrenheit, which is 840 degrees Fahrenheit, but lower than the melting temperature of the base metal. So the molten filler metal is drawn into the space between the closely adjacent surfaces of the parts to be joined by capillary attraction. So we can see in the picture, there are three common processes in brazing itself. There are soldering, brazing, and braze welding. Next, heat sources of brazing. So basically, it typically provided by a handheld torch, a furnace, or an induction heating system. There are torch brazing, induction brazing, continuous furnace, retort or batch furnace, vacuum furnace, and flux. Torch brazing means a heating source supplied by a fuel gas flame. Induction brazing, which means the electric coils are designed for specific joint geometries, are used to heat the part and the brazing filler material until the liquid metal flows via capillary attraction into the joint itself. Continuous furnace means conveyor belts transport
to the pre-alloyed components through preheating, heating, and post-heating zones, where the brazed alloys reaches temperature, then resolidifies during cooling. Retort or batch furnace use can be refractory line and heated by gas, oil, or electricity. Vacuum furnace means a furnace with electrically heated elements that surround the workload and the heat brazing filler metal to the liquid state, so the flow itself and the capillary attraction are achieved. However, in this vacuum brazing has limited application for copper, phosphorus, and silver brazing alloys. And the last is flux is the key to good brazing practice, and many problems arise from the incorrect selection or ineffective application of flux. In brazing itself, there are some principles that require to produce a good brazing, which are proper joint design, clean materials, correct alloy selection, a compatible flux or atmosphere, and controlled heating technique. The advantages of brazing itself are lower temperature, easily assembly, wide assembly or realignment, join metals of different thickness, and also join different types of metal. However, the disadvantages of brazing itself, such as lower tensile strength and not efficient method for thick metal and large parts. So there are several applications of brazing process that can be found, such as in installation of cooling, heating, refrigeration system, domestic and industrial cooling and heat exchangers, diamond tools and hard metal, solar panels, lighting and light fixtures, radiators and towel warmers, measuring and calibration instruments, electromechanical system, automotive, and others. So those are the brazing application.
What is actually a soldering process? A soldering process is a joining process, which is the joining process that produced by heating below 800 Fahrenheit. This process using a non-ferrous filler material with a melting point below that of the base metal. The metals to be joined dictate the flux, solder, and heating methods to be used. Base materials are selected by specific properties such as electrical conductivity, weight, and corrosion resistance. As you can see, maybe it is very common for you if you hear soldering process, like when your father soldering your television, or maybe radio, or maybe some computer component like that. So for the equipment and the tools for the soldering process, there are soldering irons and station, solder roll, and soldering accessories. For the soldering iron and the station, you can see in the picture, and there is like on the gun for the soldering process, and for solder roll, we usually use on the roll solder material. For the soldering accessories, there are on the workstation and the wax for the soldering process. So this is the step of the joining process. The first one is joint fitting, which is as like its name, it must fitting the joint. So the soldering get enough clearance for the process. After that, we go to the cleaning process. There are two types of cleaning, which is mechanical and chemical. For the mechanical process, we can cleaning the material, like the specimen, using clothes, or maybe some um, tissue maybe. And then after that, for the chemical cleaning, we use acid to remove the dust, or maybe another liquid that can replace the acid. After that, we go to the process of application of flux. At this flux, you must remember that the flux will be capable to remove oxides and stop them from being reforming. And And then the flux should permit displacement by the solder. And the last, the flux should promote wetting of the surface by the solder. After that, we go to the next process, which is application of heat. At this process, the heating the joint evenly or uniformly is of utmost importance to ensure a sound joint. There are types of soldering equipment like soldering irons for electrical, plumbing torch, propane low heat, deep soldering, large tank with molten solder to solder multiple joints, often heat, which is only used in production where other heating methods are impractical. After that, we got in the next process, which is applying the solder take place in two steps, which is wetting the metal surface. After that, filling the gap between the wet surface with solder. After all this process complete, we go to the last part, which is cooling the joint. At this process, as soon as the possible after the soldering process, the material should be cooled using water spray or maybe air blast or maybe another liquid that can um, faster the cooling process. After that, we go to the next process, which is flux residue treatment. At this treatment, non-corrosive flux are one which are rosin based and do not require removal. Corrosive flux are flux containing zinc chloride. Removal is must to prevent the corrosion. So the advantage of the soldering process, the first one is this process can be operated at low temperature. Base metal doesn't melt. Any metal or non-metal can be joined by this process. This operation require a low power and then less time required to join. And the last is this can be easily operated. The disadvantages of this process is the first one. Strength of joint is less. This is not useful when joint works under the high temperature. It is not useful at long length welding. The heavy metal cannot be welded by this operation. And the last is there is a chance of toxic component at the flux. So the application of the soldering process. The soldering process is commonly used in the electrical devices, heating, air conditioning, mechanical, fire sprinklers, and other similar systems as well as the radiator manufacturing, repair, and sheet metal works. So the soldering process is not basically usually used for the electronic devices only, but there are a lot of the soldering process used in the jewelry process. And then there's also at the plumbing repairing, we use the soldering process also.
The next is adhesive bonding. So here we will see how adhesive bonding works. Before that, let's see what is the principle of adhesive bonding. Adhesive bonding is a process of joining materials in which an adhesive is placed between the weighing surfaces of the components called adherents. This joining technique involves glues, epoxies, or various polymer agents. This is the illustration of how adhesive bonding works. So basically, there are two surfaces that join together using an adhesive materials between them, and these two surfaces will be joined permanently after a certain amount of time. The next one is basic types of adhesives. Actually, there are many types of adhesives that characterized by many different characteristics also. However, the one that listed below is the types of adhesives that based on the material. The first one is that natural or organic adhesives. The second one is inorganic adhesives, and the third one is synthetic organic adhesives. The next is the advantages of using adhesive bonding compared to the other joining method. The first one is fast and cheap joining technique. And the second one is the adherents are not affected by heat. Like we just apply the adhesive and directly join the surfaces together without any heating process. And the third one is uniform stress distributions, means that the stress distributions will be uniform all across the joint of a lab area. And then the fourth one is possibility to join large structures. And the last one is ability to join different materials. Like they can make gas-proof and liquid-tight joints. And the next is the disadvantages of using adhesive bonding compared to the other joining method. The first one is requires extensive surface preparation before bonding. Um, for example, like we need to make sure that the surface is dry enough to have a good finishing. And the second one is decreased stability in high temperatures. The third one is health and safety issues. Due to the basis of the adhesive or chemical compounds, it is necessary to define the necessary actions to prevent human exposure to these products during the time of applications. And the fourth one is needs additional pressures. Like if we want to make the joint strong, we need to have additional pressure. And the next is some adhesive needs long cure time. And then the last one is permanent joint. Like it will be hard on a bonding test if we have a permanent joint, because it will hard to break the joint. It will hard to break the joint. The next one is the application of adhesive bonding. Basically, the application of adhesive is the same, which is to join one part with the other parts. However, the one that you can see here is the mass application of adhesive bonding, which is used in automotive, sheet metal joining, and the last is aerospace. Now we are in mechanical fasteners part in manufacturing process. Fasteners is a mechanical element which holds two or more parts of machine of a structure without the use of outside assembly device. The process of fasten is called as fastening. Fasteners are classified into two parts. They are detachable fasteners and non-detachable fasteners. This is the explanation of detachable fasteners. The detachable fasteners is the fasteners that does not involve destruction during the separation, and the detachable fasteners spread again into two types. They are non-threaded fasteners and threaded fasteners. As what you can see in the screen, they are the non-threaded fasteners in detachable fasteners. The non-threaded fasteners has four major types. They are nails, rivets, steppes, and special fasteners such as cutter pin, corrugated fasteners, brazing pins, and Scotch fasteners. Based on the name, it obvious that the non-detachable fasteners is the opposite of detachable fasteners. Therefore, in non-detachable fasteners, it involves destruction during the separation. Because of the non-detachable facets involve destruction during dispersion, therefore, the process in non-detachable facets mostly use heat for holds the part. The major in non-detachable facets are press fits, shrink fits, using adhesive component, welding, and brazing and soldering. Now we are in mechanical fasteners part in manufacturing process. Fasteners is a mechanical element which holds two or more parts of machine of a structure without the use of outside assembly device. The process of fastening is called as fastening. Fasteners are classified into two parts. They are detachable fasteners and non-detachable fasteners. This is the explanation of detachable fasteners. The detachable fasteners is the fasteners that does not involve destruction during dispersion, and the detachable fasteners spread again into two types. They are non-threaded fasteners and threaded fasteners. As what you can see in the screen, they are the non-threaded fasteners in detachable fasteners. The non-threaded fasteners has four major types. They are nails, rivets, steppes, and special fasteners such as cutter pin, corrugated fasteners, gazing pins, and Scotch fasteners. And this is the threaded fasteners and detachable fasteners. In threaded fasteners, there are external threads such as the bolt and screw that will go through the internal thread. The internal thread such as nuts and threaded hole. For the threaded hole, you need to make it before the external thread go inside it. Based on the name, it obvious that the non-detachable fasteners is the opposite of detachable fasteners. Therefore, in non-detachable fasteners, it involves destruction during dispersion. Because of the non-detachable fasteners involve destruction during dispersion, therefore, the process in non-detachable fasteners mostly use heat for holds the part. The major in non-detachable fasteners are press fits, shrink fits, using adhesive component, welding, and brazing and soldering.
For the last one, we have shielded metal arc welding, or we can call it SMAW. Shielded metal arc welding, or stick welding or manual metal arc welding, uses a metallic consumable electrode of a proper composition for generating arc between itself and the parent workpiece. The molten electrode metal fills the weld gap and joins the workpieces. The electrodes are coated with a shielding flux of a suitable composition. The flux melts together with the electrode metallic core, forming a gas and a slag, shielding the arc and the weld pool. The flux cleans the metal surface, supplies some alloying elements to the weld, protects the molten metals from oxidation and stabilizes the arc. The slag is removed after the solidification. Next, we are moving to the advantages and disadvantages for SMAW. So the advantages for SMAW is simple, portable, and inexpensive equipment, and its wide variety of metals, Welding position and electrodes are applicable and suitable for outdoor application. But for the disadvantages, the process is discontinuous due to limited length of the electrodes. Weld may contain slight inclusions, and fumes make difficult the process control. And last is the application of SMAW. Actually, SMAW is one of the world's most popular welding process. It's accounting for over half of welding in some countries. Because of its versatility and simplicity, it is particularly dominant in the maintenance and repair industry and is heavily used in the construction of steel structures and industrial fabrication. For example, for making of bridges, pressure vessels, nuclear power plant, and for the household products, we can use it for the mining, oil industry, boilers, and etc. Okay, thank you for your attention. May this video help you and have a nice day.